Topic 1. Separating solids from liquids. Gravity forces. If a cloudy liquid is allowed to stand for a while, it slowly becomes clear by the effect of gravity, G. The solid particles sink to the bottom. Separation, as this is called, is complete when all the solids lie on the bottom. The liquid can then be poured off, leaving the solids. Separation time. The time that is required for separation to occur depends on the speed that the particles sink and the distance the particles must travel. Bigger particles sink quicker. Decrease the distance. In a tank of this shape, the solids have a shorter distance to travel. The cloudy liquid is fed in at one end and overflows at the other. The solid particles move in two directions, downwards due to gravity and sideways due to the liquid flowing towards the outlet. Increase the speed, but if the feed rate is high, some of the particles will not have time to reach the bottom and they will flow out together with the liquid. An even shorter distance to the bottom is required. But how? Fit in plates. Well, you can fit in plates like this. Then the distance the solid particles have to travel would be very short. This is an effective way to increase the speed of separation. Topic 2. Separation of two liquids. Liquid layers. Gravity can also be used to separate two liquids that do not dissolve into each other. Liquids like oil and water, for example. When separation commences, three layers are formed. The interface in the middle gradually becomes less and eventually forms a thin dividing layer. One inlet and two outlets. In the same way as with the solid particles, this separation process can also be made continuous. The feed comes in at one end, but now, of course, two outlets are necessary, one for oil and one for the water. U-tube. Let's take a look at the U-tube, as it is called. The lighter oil is pushed upwards by the heavier water. Our liquid mixture flows in through the inlet and finds its way under the baffle plate, where it creates an interface. Weir. By fitting a weir in the lower outlet, the level of the interface can be regulated. The height of the weir is important. If it is too low, some of the oil will flow out with the water. Adjust the weir so that it is too high, and the reverse happens. Some water will flow over with the oil. Topic 3. Stokes' Law. Stokes' Law. Click the letters in the formula to get more information. V. D. Full formula. Full formula. G. 18. U. So, can we increase the speed of separation? Stokes' law. Yes, by increasing the force of gravity, G. This force can be increased thousands of times by replacing gravity with centrifugal force, C, generated mechanically. Click the letters in the formula to get more information. Centrifugal force. Let's take the tank in our example. Turn it on its side and make it cylindrical so that it can rotate. we turn it faster and faster. Centrifugal force becomes greater and greater. What happens in the revolving tank, or bowl as we call it, as it spins? Separation takes place, but not very efficiently, due to the distance the heavy phase must travel to reach the wall. Topic 4. Disc stack. Bowl discs. Remember the plates we fitted into the stationary tank? Well, here we fit cylindrical inserts. To allow the particles to slide off the cylindrical inserts and move outwards, we made them conical and changed the bowl shape to suit them. Holes in the discs. Another improvement was to make holes in the discs. This enabled the dirty oil mixture to be distributed through the entire disc stack. Topic 5. Gravity discs. The interface, and consequently the liquid phase we want cleanest, is regulated by the size of the gravity disc. Gravity disc, large hole. Gravity disc, small hole. Topic 6. The bowl. The bowl. The bowl is the most important part of the separator. We mount it on a spindle and fit it with a drive and electric motor. These are then fitted to a frame with collecting covers on top. The result is a centrifugal separator. Topic 7. Basic types of centrifugal bowls. The basic type of centrifugal bowls are solids retaining separator, solids ejecting separator. Click the centrifugal bowls to get their functions. This is a solids retaining separator. It's used for separating liquid mixtures that have only a low amount of solids in them, approximately 0.1%. This is because the machine must be stopped, the bowl dismantled, and the solids removed by hand. Alfa Laval recommend these are used for cleaning distillate fuel and the lube oil of diesel engines burning distillate fuel. For liquids with a higher solid content, up to 10%, or when it's undesirable to stop the machine for emptying, a solids ejecting PX type separator is the one to use. The solids that collect in the bowl are shot out by periodically uncovering slots in the periphery of the bowl for a fraction of a second. Alfa Laval recommends that these are used for cleaning heavy fuel oil and the lubricating oil of trunk engines burning heavy fuel.